Here we're going to look at the AS Edexcel January 2023 paper, WPH12, question number 12. So, in an experiment to determine the refractive index of glass, a student directed a ray of light towards a glass prism. The ray of light is shown before and after after entering the prism. So here we've got air. Here we've got our glass triangular prism. We've got an angle here showing of 32 degrees and an angle here showing of 50 degrees. And it says determine the refractive index of the glass. Now, to answer this, we need to know Snell's law. And Snell's law is n1 sine theta 1 equals n2 sine theta 2. Normally at GCSE level, we just do n equals sine angle of incidence divided by sine angle of refraction, because the refractive index of air is 1. Now here, the other thing we need to know is that whilst it looks like they've given us the angles, they haven't really, because we need to find the angle of incidence, which is between the normal and the ray of light, and we need to find the angle of refraction, which is between the normal and the ray of light. And in both instances, we don't actually have that. So first of all, we need to draw in our normal, which I am going to sketch very badly, may I add. I'm going to sketch here. That's better. So here's our angle of incidence, and here is our angle of refraction. So how do I actually find the angle then? Well, this line here, I hope you can see, would make an angle, if drawn properly, of 90 degrees. So basically 90 minus 32 will give me 58. And over at this side, if it was drawn perfectly, it would be 90 minus 50, which is 40. That's degrees for both. So the angle of incidence is actually 58 degrees, and the angle of refraction is 40 degrees. I've got to use the equation n1 sine theta 1 equals n2 sine theta 2. So I know the refractive index of air is 1. I've got my angle of incidence, which is 58. I want to find the refractive index of glass, which is n2, and I've got my angle of refraction, which is 40. So what can I do here? Well, I can rearrange the equation to get me n2 over 1 equals sine 58 over sine 40, basically cross multiplying. And if you plug the numbers into the calculator, it will get you 1.32. Remember, refractive index does not have a unit. Refractive index is a measure of how much light is basically bent inside a glass, how much its speed changes, how much its direction changes. It says on the next part, draw on the diagram the ray of light as it emerges from the prism at A. No further calculations are required. Now, they want you to draw it up here, but I have just repeated the diagram down the bottom here. And what we're looking at is we're going from glass to air. We're going from a more dense medium to a less dense medium. Now, if I can sketch the normal again, so where light strikes it, it's at 90 degrees. So a normal is at 90 degrees to where light strikes the boundary. So light strikes the boundary where I've drawn that black dot. The normal is at 90 degrees to that. And when you're going from more dense to less dense, the light is bending away from the normal. And it's just a sketch. They don't require you to measure the angle exactly. And that's what that diagram shows.